Pre-Algebra Lesson 3-1, Rounding and Estimating. Many real-world problems require only an estimate for an answer, while others will require an exact answer. For example, if I'm building a bridge, I want an exact answer. I don't want the bridge to collapse. However, if I'm going grocery shopping, I can give an estimate if I have $100, if I'm estimating, and I go, okay, I'm going to spend $95. There's a pretty good chance I'm not going to go $5 over. So today we'll be looking at rounding and estimating decimals. Now, when you do not need exact answers, you can round. Let's refresh our rules for rounding. Look at your place value. Look at the number to the right of the digit to be rounded. If that number is a 5 or greater, round the underlined value up and put zeros in the remaining places. If the number is 4 or less, leave the digit to be rounded alone. In other words, leave the underlined digit alone and put zeros in the remaining places. And just in case you forgot, here's a quick little overview of your place value. Okay? If my decimal point is here, the first place after it is the tenths, then we have the hundredths, then the thousands, and then the 10,000s. We don't have a once place. To the left, you have ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions, and you have 10 billions, 100 billions, and then trillions, and et cetera, et cetera, et cetera. You can continue going out in either direction. As long as you can count your place values, you'll be pretty set. All right, let's round this number. Okay? We're going to round 4.238972. Or, if I was going to read this number, for those of you needing to read this number, here's my last digit. Okay? Tens, hundreds, thousands, 10,000s, 100,000s. After 100,000s, okay, comes millions. So this is the millions place. So it's 4 and, then you read this, 238,972 millions. Okay, for those of you who aren't really good at reading these numbers, the more you read them, the better you'll get it. All right, first thing we're going to do here is we're going to round it to the nearest tenths place. So I'm just going to rewrite the number, 4.238972, so I can underline my tenths place. My tenths place is right here. So I'm going to look to the digit to the right of the tenths place. It is not a 5 or greater. Therefore, I'm going to leave the 2 alone, and everything after that becomes a 0. So it's 4.2. And I can put a 0 in all those places, or I can just leave it as 4.2. I have to have a digit in the tenths place because they asked me to round to the tenths place. But once I've rounded to the tenths place, if everything after the tenths place is a 0, I don't have to write in all those zeros. As long as I have a number in the place value I was asked to round to, I don't have to have any of those extra zeros. Let's look at this. Now we're going to round it to the nearest 1, or a whole number. So 4.238972 to the nearest whole number is here. If I look to the right, it is not a 5 or greater, so this would round to just being 4. I could put 4.000, but I don't need to. It's just 4. It's to the nearest whole number. If I take it to the nearest 10,000s, 4.238972. Tens, hundreds, thousands, 10,000s is the 9. If I go to the right, it's a 7, so it's higher than 5, which means that 9 rounds up. That 9 rounds to a 0 because it has to round to 10. That 10 gets put with this 8, which that makes that round to a 9. Then this is a 3, this is a 2, this is a 4. And I have to keep this 0 because I have to have a digit in the 10,000s place. I cannot round this into 4.239. I have to round it to 4.2390 because I have to have a digit in the 10,000s place. I must have a digit in this place value. Since they asked me to round to the nearest 10,000, I have to have a digit in the 10,000s place. So in this case, since it rounded up to make it a 0, I have to keep that 0 in that 10,000s place. Right. These next numbers say identify to the underlined place value and then round to that place value. All right, 38.41, the 4 is in the tenths place. We're going to round to the nearest tenth. You notice that the number after the 4 is not a 5 or more, so we just need to round this to 38.4. 0.7772. 0 is in the ones position, because it's right in front of the decimal. Since the number after the 0 is a 5 or greater, it rounds the 0 to a 1. And I can just leave it as 1. I don't need the 0.0 because I have a digit in the ones place. That's as far as I have to round it to because it said I only have to be as accurate as to the ones position. Here we have 7,098 and 56 hundredths. The 5 is in the tenths place. I look to the right, it is a 5 or greater, so 7,098.6. 274 and 9,434 ten-thousandths. The 3 is in the tens, hundreds, thousandths position. Okay, the 3 is in the thousandths position. The number after it is a 4, so it's not higher, so I would just leave the 3 the way it was, 274.943. Number 5, 5.025, or 5 and 25 thousandths. The 0 is in the tenths place. The number after it is not a 5 or greater, so this becomes 5.0. And yes, you have to keep the 0 to prove that you rounded to the tenths place. We must have a digit in the tenths place. Number 6, 142.89. The 2 is in the ones position. If we go to the right, it's 5 or greater, so we're round to 143. 389 and 5,672 ten-thousandths. The 8 is in the hundredths place, not hundreds, hundreds. Make sure you know the difference between DS and PHS. This 1 is after the decimal point, 1 is before the decimal point. If it ends in DS, then it's before the decimal point, and PHS after the decimal point. I look to the right, it rounds it up, so it's 390. And last but not least, 34 and 287 thousandths. The 3 is in the tens place. Ooh, which means the other one was in the tens place too, wasn't it? This is the hundreds place, this is the tens place. Tens. Right? Tens place versus tenths. So it's still THS versus NS or DS. Okay, tens position. If we go to the right, it is not 5 or greater, so this is 30. All right, let's take a look at some other things. Now, when rounding to a place that is to the left of the ones place, you replace the digits between the rounded place and the decimal point with zeros. That's imperative. You have to do that. When rounding to a place to the right of the decimal point, you drop the digits to the rounded right of the rounded place. All right, one way to estimate is to round all your numbers to the same place value. So if we're going to estimate by rounding, if we look at these two numbers, 355.302 and 204.889, if I'm going to round these, I want to round them to something that will be a little easier to add. So I'm not going to round them to the tenths position. I'm going to round them to the nearest whole number. Okay? So I'm going to round 355.302. That's going to be approximately 325. So I'm rounding to the nearest whole number. 204.889 is approximately equal to, if you look at this, it's going to round up to 205. Now, if I add these together, this is simply 560. And that's a good estimate. Notice I'm using the approximately equal to symbol to show that it is not an exact answer, but an estimated answer. Okay. I look at 453.56 minus 230.07. The whole idea of rounding is to make it easier to add. You don't want to round ridiculously. I'm not going to look at 453 and go, oh, I'm going to round that to 500. And take 230 and, oh, I'm going to round that to 200. Okay? Because you want it to be somewhat accurate. So the most I would round this to is the nearest tens place, but you can round it to the nearest whole number if you wanted to. I'm going to round this to the nearest 10. Okay, so I'm going to round it to the tens position, okay, which means this would round to 453.56 would round to 450, and 230.07 rounds to 230. 450 minus 230 is 20. Approximately 20. Another way of estimating is using what we call front-end estimation. Front-end estimation is often closer to the exact sum than an estimate done by rounding. It's a little weird. I don't do it often, but I do it once in a while, so it is important to understand it. With front-end estimation, you're going to add your front-end digits. In other words, add whatever digits are your first digits. Okay? Round to estimate the sum of the remaining digits, and then combine your estimates. Now, let's take a look at an example here. It's going to be a whole lot easier to understand. Okay? So I'm going to take 6.75, 2.2, and 9.58. Okay? First thing I'm going to do, I'm going to add my front digits. Okay? Because it says front-end estimation. We're going to add those. 6 and 2 is 8, 8 and 9 is 17. Put my decimal point here. Now I'm going to round these. I'm going to round them to the nearest 10 because I can't round any more than that because there's not a nearest 10 past this number 2 here. So 0.75 rounds to 0.80. 0.2 stays as 0.2. 0.58 rounds to 0.60. Okay? If I add these together, I get 1.6. If I was going to add 17 to 1.6, that becomes 18.6. And that's rounding by front-end estimation. Okay, kind of different, but a little bit more accurate than rounding each one of these. Like if I rounded this 6.75 to 7, so if I rounded 7, 2, and 10, that would give me 19. This is a bit more accurate. Okay? It's a bit more accurate. Not exact, because it's still an estimation. All right, let's take a look at this next one. 1.07, $2.49, $7.40. Add my first digits. It's 10. Plus, I am around these to the nearest 10 cents. So this would be 10 cents. This would be 50 cents. And this would round to 40 cents. That's another dollar. If I add 10 plus 1, I get approximately equal to $11. Now with estimates, there's a bit of wiggle room. Obviously, depending upon where you estimate to, will be depending upon whether or not you get closer to the exact answer or not. There's always going to be a little bit of margin of error with an estimation. If somebody had estimated slightly differently and got 10.8 versus 11, that's fairly close. But if they got 15, that would be way off. The last type of estimation is using clustering. I like clustering because it makes things really easy. Clustering can be used to estimate the sum of several numbers that are very close to the same value. For example, if I have $4.50, $5.20, and $5.55, they're all really close to $5, aren't they? So I can look at these and go, gee, these are all really close to $5, and there are three numbers all very close to $5, so it's approximately $15. That's what clustering does. It works really well to estimate the sum. It's not used to estimate the difference, only used to estimate sum. So let's take a look at this. We're going to estimate using clustering. 26.7, 26.2, 24.52, 25.25, 23.9. These are all very close to 25. A little above, a little above, a little below, right on, a little below. So they'll balance out to about 25. And there are 1, 2, 3, 4, 5 of them, 5 numbers at about 25, which means approximately 100. And that's a fairly close estimation. If we look at number 2, $81.75, $79.56, $80.89, all of these are very close to $80. That's a nice looking C, isn't it? Wow, that's a really looking C. There you go. Since they're all close to $80, there's 3 of them all close to $80. 8 times 3 is 24, so it's all close to $200. rise. So you can see how the different types of estimation can help you be able to make your math a little faster. The whole point of estimation is when you actually do an answer, if you've already estimated it and your answer is nowhere near your estimate, something is wrong. Either your estimate is off or your answer is off. Normally your estimate is pretty decent and you've made some sort of computational error. I like to estimate when I do any kind of shopping so that I know how much money I'm going to have to spend when I get up there. So that if it comes out to be a ridiculous price, I can say, hey, wait a second, something didn't ring up right. Because in my mind, I should have only spent $110 and you have me spending $170. I can't be $60 off. Right? So estimation it's a great skill to use outside of in the real world when you go out and do all kinds of different things. There's times when estimation works really well, and there's times when you need an exact answer. Just make sure that you know when you need an exact answer, it should be exact. Right? Building a car, building an airplane, I want exact answers. Don't estimate on that for me. I don't want anything crashing.